So why don't we just go there for a little trip from Louisville? So here we are in Louisville. There's the stadium, there's the university, there's the downtown. So let's pull back and head north. There's the airport, the Ohio River, starting to see Kentucky. There we are, coming all the way back out, land between the lakes. The Great Lakes themselves, carved out by the Great Pleistocene ice sheets. We had ice and snow covering this particular area all through the last 20,000 years. All these were carved out. We had ice just north of Cincinnati. All of this area was totally coated in ice, all through the Canadian Rockies, all the way up. Interestingly enough, Alaska had very little at that time. The sea ice was entirely frozen at that point, and the air was so dry that the north slope of Alaska received very little in the way of glaciation. The only exists there now is in the Brooks Range itself. But imagine the magnificent changes that must have taken place. So here we are, up into the Davis Straits, up into Baffin Bay, Hudson's Bay, Greenland ice sheet itself, one of the last of the major surviving ice sheets, up into Iceland. And if we think about this, the interesting part is that in the 1830s and 1850s, the exploration that took place, they would bring ships. They were looking for the Northwest Passage, a way to find commerce. Instead of having to move all the way down through the Cape Horn region, they could travel through this area. Many people died. Many expedition was failed and lost. Coming up through here, here's Baffin Island, Ellesmere Island, Devon Island, trying to come through Lancaster Sound. People were never seen again. And so the search for the Northwest Passage was really consequential. And it wasn't until 1900s that they actually broke through it. And now, with the reduction of the ice, the Northwest Passage is essentially free. You can paddle a canoe through it. This has enormous changes and consequences, not just for the climate, but for our geopolitical environment. The North Slope up in here, up in this particular, the Northeast Passage, the interesting part here is that along here, the continental shelf moves out from Northern Europe all the way through here, all the way out through here. So now the question is, who owns this particular property? A part of the world's largest existing known reserves of natural gas and oil are in here, and now we can float boats through here to have access to it. So it's enormously consequential. And this is extremely deep. You can now take a boat quite easily to the North Pole. So let's see what this means in terms of sea surface temperatures. Now, we're going to rotate it around, and here we have the mighty Gulf Stream moving up. It takes a warm current of water all the way up into Baffin Bay, around the eastern coast of Greenland. Notice that Iceland is essentially ice-free. There's no barriers of ice. They're all contained to the north. Interesting here, if we move up over Norway and Scandinavia, this particular current kept all the areas in the north free. The Baltic Oceans, the Baltic Seas in through here were always frozen, but areas far to the north were heavily contested as a geopolitical area in the Second World War. So we see these ocean currents and these temperature structures brought to us by the ocean as also a regulator. So as we begin to change the physical structure of the sea ice, we're running fresh water into the oceans, we're changing the density, we're going to overturn the major circulation systems here, and it's another major pulse of climate change. So why don't we just use this magnificent technology and head south? So what we will, we'll rotate down, come down over the America, Cuba, Florida, Central America, down through Chile, Argentina, and we'll start to see the Antarctic Peninsula move on out, up into the Ronne Ice Shelf, over to the Ross Embayment. And the thing to notice here immediately is that notice Antarctica sits right in the middle of the southern oceans. Most of the world's landmass exists in the northern hemisphere, so there is a totally different climate. So Antarctica itself is an enormous regulator. The interesting thing about the Antarctic is that you can see this particular band here of mountains, the Transantarctic Mountains. Antarctica is in fact not one continent, but two. It's two continental plates that have moved together. And this is the West Antarctic ice sheet, and here's the East Antarctic Plateau. The interesting thing is that if we remove all this ice from the West Antarctica, we would have this tiny little archipelago of islands. And in each case, we would change the entire direction, the entire southern circulation system. So it is an enormous regulator, not just of the southern hemisphere, but in the same way that the North Pole is the regulator for the northern hemisphere. So let's just have one more thing, and we'll switch on the sea ice. That's the extent of Antarctica. Antarctica is an interesting continent. It's 3 times higher than any other continent. It is the only continent that increases in size because its size is regulated by the actual margins of the sea ice. So it grows every year. And these particular changes are enormously consequential. And the southern hemisphere climate system, when we see changes in this massive ocean system, then we really do know that this is a global climate change. So there is much to be learned from us for this. And I will leave it there and let other people move on. Thank you, Dr. Connolly.
Thank you, Keith. That was wonderful.